At the beginning of this section, I gave you 6 basic trig derivatives. One of the things I need to show you is how these derivatives came about. So I picked the tangent to prove this rule. So we know that the derivative of tangent is secant squared, and I actually want to do it as a proof. So the way that proofs work in math is you work one side down until you get the other one. So what I know about the tangent is the tangent equals sine of x over cosine of x. Now, what I can do with that fact is recognize that it's a quotient, and I can take the derivative using the quotient rule. So quotient has a high function and a low function. So my high function is sine of x, and my low function is cosine of x. Well, I know that the derivative of sine is cosine, and I know that the derivative of cosine is negative sine. Okay, so let's take the derivative over here on the blue side. We would say low d high minus high d low over low squared. Low d high minus high d low over low squared. When I simplify this out, I recognize that I have cosine squared of x over here. On the right side, I have 2 negatives. Well, 2 negatives multiplied together give you a positive, and sine times sine would be sine squared. From previous facts, I know that cosine squared of x plus sine squared of x equals 1, back from trig. So this top part here is going to equal 1. So what I'm going to get is 1 over the cosine of x squared. Well, you can write that another way if that makes it easier. That's 1 over the cosine squared of x. And when cosine is in the bottom, that is the secant. So if I have 2 cosines in the bottom, that means I have 2 secants. So this would equal the secant squared of x. And we have proven that derivative.